All right, so this video is going to go over the impulse and momentum review. So one thing I want to say is that this is pretty much one of our shorter reviews. So if I were to do this, if I were to get ready for this test, what I would do is I would do this review and I would go back and look at, I'd look through the whole packet, look for anything like conceptual stuff that may be answered with words instead of just doing numerical answers. Okay, but if I were to go back and kind of pick some things to look at, is one is your 9 through 11 homework. Okay, so that's when we talked about J equals F times T, P equals M times V, because that was our basic kind of getting into that groove kind of thing. And then I would go back and at least look through the 12 through 13 pages in your packet that goes over the graphs. So I'd really understand how to do that graph stuff, which I'm going to go over some graph stuff in here. Okay, and then that pages 19 through 21 where it goes over the three different types of momentum, okay, or collisions in that case. So those are some things I'd go back and look at if this review is not enough to study for. Okay, if you're wanting more to look at, those are the things I would recommend. Okay, so now we're going to get into this review. So this first problem right here is a 15 kilogram child is running at 3.0 meters per second. West, when she jumps onto a 4 kilogram skateboard, which is at rest, what is the velocity of the skateboard after the child has jumped on it? Okay, ignore friction. Okay, so there's a couple of things I want to talk about. First is there are three types of collisions. Okay, the first one is where they're separate in the beginning. So this would be like an M1 V1 initial plus M2 V2 initial. Okay, so that just means there's two different masses going on and they each have their own velocity, which means they have their own momentum. Okay, then they hit and then they stay separate. So it's going to be M1 V1 final plus M2 V2 final. Okay, so that means is once we know this total momentum over here, okay, so this is the individual momentum here, this is individual momentum here. What you would do is you could add those up and that gives you one big momentum. Okay, that's your total momentum on the left side. And you have your individual momentum over here, your individual momentum over here. Add those up and you get a total momentum on the right side. Okay, the important thing is that total momentum before equals the total momentum after. Okay, so notice that I'm saying total. These little individual momentums can change. Okay, they can be their own thing. Okay, so, but once you add them together, they're going to equal out a total momentum. And remember, momentum, total momentum is one of our conserved quantities. So it's important to know that things that can change is your individual velocities can change. Okay, so all these can change. So an object hits another object, it's going to change its velocity. It's going to change its individual momentum. Okay, but overall total momentum will stay the same. Okay, so let me clear this up a little bit. Just kind of get rid of this P stuff and the markings there. Okay, so that is your first equation right there. That is a type 1 where they're separate in the beginning and then they're separate in the end. Okay, now if you have your type 2, this is where you have M1 V1 initial plus M2 V2 initial. They're separate in the beginning and then they stick. Okay, so again, I will give you this first equation. Okay, I will not give you these next two. But you've got to understand is if I say they stick together, that means after they hit, there only can be one mass, M total. That's where you just add them up. And then your final velocity, there is only, if you're stuck together, there is only one velocity. Okay, so you're just no longer separated in the end. That would be a type 2 problem. Now, type 3 is typically like your gun, your explosion. Okay, that's where they're together in the beginning, and then they separate. So in the beginning, you have one mass. So like if it was like a gun and a bullet, it'd be the gun and the bullet together. Okay, then you have your initial velocity, which usually is going to be 0, okay, because nothing's ever happening before the explosion happens. So usually this left side is going to equal out to 0 anyway. So it doesn't even matter. You can add up the masses if you want, but anything times 0 is going to be 0. Now, the explosion happens and then it separates. Then it goes M1 V1 final, so one piece goes one way, okay, with its velocity, and then one piece goes the other way. That's your M2 V2 final. So those are your three types. So now looking at number 1, we basically have a kid running at a skateboard. The skateboard is on its own. Okay, so they're separate in the beginning. Then the kid jumps on the skateboard, and we want to know how fast they're going after. So this is where 2 become 1. So we have the mass of the child. So we have 15 kilograms. And they're going 3 meters per second. Plus the 4 kilogram skateboard. So that's 4 kilograms. It's sitting at rest. Okay, so its velocity is 0. Equals, now they're together, so our mass total, so 15 plus 4 is going to give me 19. And we want to know what is the final velocity of the kid and the skateboard. Okay, so solve for VF. And you should get a final velocity of 2.37 meters per second. Okay, so that'd be your answer right there. So that was a type 2 problem. And again, I'm not going to ask you what type these problems are. I could care less about that. It's mostly, do you know that they're separate in the beginning and you know to combine the masses into one mass and one velocity in the end? Okay, so can you manipulate this equation right here, this first one, and make this equation right here? Okay, so that's the important part. I could care less about what type it is. It's just, can you manipulate the equation to what you need? All right, so looking at graph stuff. So this graph, I have a 0.5 kilogram object. So there's your mass. So don't look over the stuff that we give you. Is initially moving at 5 meters per second. So there's your VI. When it's acted upon by a force described in the force versus time graph below. Okay, so remember area under the curve. So area equals momentum equals change in momentum equals impulse. So if I ask you for anything like that, if I ask you what is the momentum up until this time, if I ask you what's the impulse up until this time, if I ask you what's the change in momentum up until this time, it is just area up until that point. Okay, so just be careful of that. So what I'm gonna do is I'm gonna find the area of this graph. Okay, so I have a triangle that goes from 0 to 3, so there's your base. So remember, the area of a triangle is 1/2 base times height. So my base is 3, my height is 6, so 3 times 6 is 18, half that gives me an area of 9. Okay, now my little square down here, I have square is just base times height. So it goes from 3 to 5, so it's a base of 2. 2 times -4 gives me -8. Okay, now this graph goes all the way to 6 seconds right here. Okay, so please be careful with this. You only look for the area between the graph line and the x-axis. That means do not start calculating stuff all through here. Okay, so we could care, wherever I'm marking red, okay, we could care less what that area is. Okay, so just be careful that I've seen that happen before. Okay, so all we care about is basically those two shapes because from 5 to 6 seconds, it's just on the x-axis. So we don't have to worry about finding area for that. Okay, so it says, what is the change in momentum of the object from 0 to 6 seconds? Okay, so change in momentum, impulse, momentum is the same as me saying, what is the area up until 0 to 6 seconds? So all I got to do in this case is just 9 minus 8 gives me 1 newtons times seconds. Okay, or you could say kilograms times meters per second. That's fine. Okay, either one of those works. But the point is I just added up the areas until that point. If I asked you what was the change in momentum up until 3 seconds, it would just be 9. Okay, so just make sure that should be an easy step. Just make sure your areas are good, and then you just got to worry about just adding them up or subtracting in this case. Then B says, what is the velocity and acceleration of the object at 6 seconds? So what I'm seeing people do is they see they're right here at 6 seconds, and they look over to the left and like, oh, well, everything's 0. Okay, so that question's done. Okay, for velocity, you're using this equation. P equals M times VF minus VI. So on your formula sheet, you see this. P equals M times triangle V. Okay, that's delta. Delta means change in velocity, which is the same thing as saying M times VF minus VI. Okay, so P is the area up until that point. Okay, so at 6 seconds, what is the area up until that point? Well, we just did that in part A. Your area would be 1. If I asked you to find the velocity at 3 seconds, your P would be 9 now. Okay, so your P can vary just based on what time I ask you to stop. So in this case, we go 6 seconds, we're gonna go the whole way. So 1 equals my mass, which I already told you is 0.5. Okay, and that's gonna be times VF minus VI. Now VF, we don't know, that's what we're looking for. Minus, remember I told you up here that our V initial was 5, so VF minus 5. Okay, so there's 2 ways you can solve this. Okay, easiest way would probably be go ahead and divide both sides by 0.5. Be careful with this. What I'm seeing people do is they're doing 1 divided by 2. Okay, and that is not the same as saying 1 divided by 0.5. Okay, so be careful with that. So you could go ahead and divide both sides by 0.5 if you want to, and that'll give you 2 on the left side, and then all you gotta do is add 5 to their side, and you get a final velocity of 7. Now, you could also cross distribute. You could cross multiply in if you prefer to do that. Okay, and then get VF by itself. Doesn't matter to me. Okay, just whichever way works for you. Now, that would be your answer for velocity. So if you ever want to find velocity, this is what you do every single time. Okay. Now, if you're looking for acceleration, acceleration is F equals ma. Okay, so now what I do is at 6 seconds, where am I on my y-axis? Because y-axis is force. So in this case, it is 0. My force is 0. My mass is 0.5. And A is what you're looking for. Well, it's just going to come out to be A equals 0 meters per second squared. If I were to ask you what is the acceleration at 4 seconds, now what you would do is at 4 seconds, I would look, I'm at -4. -4 equals 0.5 times A. Okay, divide both sides by that, and you get an acceleration of -8 meters per second squared. Okay, so that's just another example on how to do that. But if you're ever looking for acceleration, this equation right here, every time. 3, a 5 kilogram object moving with a velocity of 2 meters per second to the north, so pay attention to direction, collides with a 4 kilogram object moving to the south. Okay, so we have conflicting directions, so you need to make one of those negative. It does not matter which one you do. Okay, if you want to make north negative, go for it. But you just need to remember, if you decide that north is negative, everything north past this has to be negative as well. Okay, but in this case, I always make north positive and I make south negative. That's just my choice. Okay, either one, it's up to you. So find the velocity of the 5 kilogram object after the collision if the 4 kilogram object is moving to the south at 1 meters per second. Okay, so we have 2 objects here. So this is definitely one of our 3 types of collisions. It did not mention that it's stuck at all. They didn't say that they're stuck together. There was not one thing blowing apart into different pieces. So this is your type 1. This is where everything's separate in the beginning and after. So I have a 5 kilogram object that's moving with a velocity of 2 meters per second to the north, so I'm going to make that a positive 2. Plus, I have a 4 kilogram object moving at 6 meters per second to the south, so I'm going to say that's negative 6. So don't forget the signs because that will mess up your answer if you do. Equals, they're still separate after they hit, so mass 1 is still 5. But we want to know what is the velocity of the 5 kilogram object, so we do not know what that is, so I'm going to leave that as VF. Plus, the 4 kilogram object is now going 1 meters per second south. So remember, south is negative. So 4 times -1. Now all you got to do is basically just clean that up and then solve for your VF. And you should get a final velocity of -2 meters per second. So there is your type 1 right there, where they're separate in the beginning and separate in the end. Number 4, a 3 kilogram gun fires an 11-gram bullet. Okay, after the explosion, the bullet is moving at 300 meters per second to the east. What is the recoil velocity of the gun? So this is our 3rd type. This is where you have one object that's blowing apart, and then 2 objects are now going their own separate ways. Okay, so this would be like the gun and the bullet are together, and now they're separate. Okay, so their mass total in the beginning would be 3 kilograms plus the 11-gram bullet. So remember, 11 divided by 1,000. We'll fix that. So that's 0.011 kilograms. So my total mass would be 3.011 kilograms. That's the gun and the bullet. Now the velocity of the gun and the bullet beforehand is nothing. Okay, it's not doing anything, so it's 0. So that whole left side is 0. Now the gun is 3 kilograms, and we want to know how fast is the gun going the other way. So there's your VF. We don't know what that is. Plus my bullet, which is 0.011, is now going 300 meters per second to the east. Okay, so there's my setup. So all I got to do is look for my VF. Okay, so I get my VF of -1.1 meters per second. So there is your type 3. So we've gone over the 3 different types. So you just need to see, are they separate in the beginning and separate in the end? Then it's type 1, and that's the equation we give you. Are they separate in the beginning and then they join together to become 1 in the end? That's your type 2, where you actually have to make 1 mass and 1 velocity after the equal sign. Or like this, where this is type 3, where it's together in the beginning. So 1 mass, 1 velocity in the beginning, and then it separates into 2 pieces. Okay, so those are your 3 types. Now it says, what is impulse momentum theorem? Okay, so basically this states is when you apply a force to something, so apply a force to an object, okay, its momentum can change. Its momentum will change. Okay, so if impulse, remember impulse is J equals F times T. Okay, that's your force applied over a certain time. Momentum equals mass times velocity. Now, if I apply a force to something, that's going to change its velocity, okay, which in therefore is going to change its momentum. So impulse momentum is basically stating, well, technically these two are the same thing then. So that's why we can set F times T equal to M times V. Okay, so I could really care less about knowing what impulse momentum theorem is. Okay, I care more about knowing, well, if I know that J equals F times T, but I'm looking for momentum, which is technically P, and I just gave you force and time, well, then technically I could just say P equals F times T. Or I could say J equals mass times velocity. It just kind of depends on what we're asking for. But the important thing is just knowing that you can set those equal to each other. Okay, and then if you need to, you can actually set the equations equal to each other to find the missing variable. Now it says, how are force and time related? Okay, so if I increase force, if force goes up, okay, your time will go down. Okay, so impulse stays the same. Okay, so impulse is stopping an object from moving. Okay, so what I want to do is I actually want to, let me clear this up. When I want to stop something, okay, the reasons why you would rather land on a pad or a pillow is because what I want is I want time to go up. Okay, if J is impulse, which means you're stopping, you're going to stop no matter what. If you hit a pillow, if you hit the hardwood floor, okay, when you hit a pillow, time to stop increases, therefore force decreases. Okay, if you were to hit hardwood floor, J would still be the same. You're still going to stop. Okay, but now time is going to go down and force is going to go up. Okay, so that means the time it took you to stop is very little, which means all of that impulse is just going to be straight force, which is what causes it to hurt so much. Okay, so that is how force and time are related. They're inverse of each other. Now, a 0.145 kilogram baseball is moving at 25 meters per second. If it is hit back at 40 meters per second, determine the impulse given by the ball. Well, impulse technically is J. Well, J equals F times T. I didn't give you force. I didn't give you time. I did give you mass and velocity. So remember, J is also equal to momentum. Therefore, equals M times V. Now, I have two velocities in this case. So this would be M times VF minus VI. So I'm going to plug in. So my mass would be 0.145 kilograms times my final minus initial velocity. Now, be careful with this. It's hit back at 40 meters per second. So really be careful with this one. That would be a negative 40 for your final minus your initial, which is 25. So there's a big difference between negative 40 and 40. Okay. So you do our math and it comes out to be negative 9.43 kilograms times meters per second. Now, B says if the ball and bat were in contact for 0.05 seconds, calculate the force exerted on the ball. So remember, J equals this. And if J equals F times T, I can use that answer to solve for my force. So negative 9.43 equals force, I don't know. And then time would be 0.5. So divide both sides by 0.05, and you get a force of negative 188.6 newtons. And that'll end it.